Have you ever tried to get an AI to read a PDF only to get back, well, complete nonsense? You'd think it would be a piece of cake for these powerful systems, but it's actually one of the biggest, most frustrating puzzles in AI right now. So let's get into it and figure out why this seemingly simple task is such a huge deal. I mean, really think about it. You can pick up a complex report, and in seconds, you get it. You see the headings, the tables, the little footnotes. It all just makes sense. But for an AI, that same exact PDF is just a chaotic jumble of letters and shapes. It has no idea what's going on. Why is that? Okay, so it all starts with something we can call the digital document dilemma. Look, pretty much all of human knowledge is stored in documents, but to a computer, they're an absolute disaster. And cracking this code, well, it's the key to everything we want from next-gen AI. We're talking about incredibly powerful search, AI assistants that are actually helpful. It all relies on something called retrieval augmented generation, or RAG. That's just a fancy way of saying the AI needs to look up facts in documents to give you good answers. But here's the catch. That only works if the AI can actually read the document in the first place. The official term for this whole process is document structured extraction, or DSE. It's basically the magic trick of turning a visual document made for human eyes into a logically structured text that a computer can make sense of. So, if it's so important, why are we still so bad at it? Well, it turns out the way we've been testing and grading these AIs has been completely wrong. The whole report card is just broken. And this slide right here just nails the problem. On the left, you see how we test AI on these tiny little isolated tasks. Can you find a table? Can you extract this one paragraph? But on the right, that's reality. Real documents are a unified challenge. You have to get how a heading on page 1 connects to a chart on page 5 and a conclusion on page 10. It's like we've been training a chef by only testing if they can chop an onion, but we never once ask them to cook an entire meal. So to fix this broken system, researchers built a brand new, much tougher task. You can think of it like a brutal obstacle course for document AIs. It's called READOC. The challenge sounds simple, but it's brutally effective. Take a whole, messy, multi-page PDF and turn it into clean, structured Markdown. Markdown is just a simple way to format text so a computer understands headings, lists, and all that good stuff. This new test forces the AI to look at the entire document, start to finish, and actually understand its structure as a whole, just like a person would. And they didn't go easy on them. This wasn't a test with clean, perfect documents. They pulled together over 3,500 real-world files from all over the place. Dense academic papers from arXiv, documentation from GitHub, and all sorts of research data from Zenodo. We're talking about a truly diverse and messy collection, which is exactly what makes this so difficult. Now, how do you even grade a test this hard? They built a really clever automated system called the Evaluation S3uite. First, it takes whatever messy output the AI spits out and standardizes it. Then it segments it, breaking it down into logical pieces, like headings, paragraphs, and tables. And finally, it scores the AI's performance on a whole bunch of different skills. It's a tough but fair judge for every single AI.
All right, so with the brutal test and the strict grading system ready to go, it was time for the main event, the AI showdown.
And they brought in everyone. You had your basic tools, your more complicated pipeline systems that kind of bolt different models together, your specialized, expert models that are trained only on documents, and of course, the big guns, the powerful vision language models like GPT-4o Mini. So how did they do, honestly? It was kind of a disaster. The best performers were the expert models, but even they only scored an 81.4 out of 100. That's a B- on a good day. And just look at the big, powerful VLMs. They're way down at 58. It's so clear that even our absolute best AI models are just not ready for this. And that leads us to the real million-dollar question. Why? What went so wrong that these incredibly powerful systems just fell flat on their faces? This quote from the paper just says it all. The AIs aren't really understanding anything. They're just doing a superficial imitation. They've seen millions of documents, so they know what a heading usually looks like, but they have no clue what it actually means or how it fits into the document's overall logic. And because they're just mimicking, they can't generalize. This is crazy. The best model, NuGet, was trained on academic papers, and it scored that 81.4. But when they gave it a wider variety of documents, its score plummeted to 49.9. It learned one specific style, and it was totally lost with anything else. And what about those big-name VLMs? Well, this chart tells a pretty damning story. The longer the document, the worse they perform. It seems like they literally lose the plot. They can't maintain the context across multiple pages, which is probably a core limitation in how their attention mechanisms work. By the end of a long document, they've forgotten what was at the beginning. So if you boil it all down, it comes to this. The single biggest challenge is understanding the global structure. Just think about creating a table of contents. To do that, you have to read a whole document, identify every heading and subheading in the right order, and that one task remains a huge unsolved challenge. It's the one thing that shows whether you truly get the big picture, and today's AIs just can't do it. But you know what? All of these failures, they aren't just bad news. They're actually giving us something incredibly valuable, a new map for the road ahead. So, what have we learned? Let's recap. 1. Our current AIs are nowhere near ready for the messy reality of complex documents. 2. Our old testing methods were basically letting them cheat, hiding these huge weaknesses. 3. The next great challenge, the next frontier for AI, is teaching it to understand that global big picture structure. And finally, and this is the exciting part, a benchmark like READOC gives us a clear roadmap, a step-by-step guide on how to build the AIs that can finally crack this problem. By pointing out exactly where things are broken, this research isn't just about failure. It's about pointing us in the right direction. It gives us a clear target to aim for. And it leaves us with this really cool question. Are we finally, after all this time, drawing the map that will let AI truly read and understand all of the world's collective knowledge?